So prior to this course, you guys, we've used like rectangular coordinates to plot points in the Cartesian coordinate system, right, with x and y. But now we're going to be introduced to a different way, um, a different set of coordinates. They're called polar coordinates, and they have certain advantages, like in biomechanics with pivotal joint movements or orbits, and so on. And so, what you have here with polar coordinates is you have what's called the polar axis. Right, here's our polar axis, and what we're going to do is we're going to rotate a theta amount. Right, so how much you rotate. Oh, why is this not right for me? There we go. Rotate. That's how much you rotate theta amount. And the coordinate is in terms of r comma theta. R is the distance out to the point P. That's our distance r out, okay? And that's the distance from what's called the pole right here at the origin. Right here is our pole, okay? So let's do this. Let's do this first one here. Here's our r, here's our theta. We're going to put that polar axis on the positive x-axis side, right? We're going to rotate 3 pi force, right? Now, 3 pi force, or 135 degrees. So let's rotate 135 degrees. So here's our 3 pi force rotation. And then we go out a distance from the pole right here. From the pole, we're going to go out a distance 1, 2, 3, 4. And we're going to plot the point right there. So that's the point. That's the polar coordinate 4 comma 3 pi fourths. Okay. I want you guys to pause the video. Go ahead and try that next one. Rotate 5 pi thirds and then go out a distance 5 from the pole. So here's our r, here's our theta. So theta is 5 pi thirds. And by the way, if you're not remembering like where is 5 pi thirds, well, just convert it to degrees if you need to, right? 180 divided by 3 is 60. 60 times 5. This is 300 degrees. So you're rotating 5 pi thirds, so 300 degrees. And then you're going out 1, 2, 3, 4, 5, and you're putting the point. That's where the point is in polar coordinates. So you rotated 5 pi thirds, and you're going out a distance from the pole, r distance from the pole. Okay, and that's, again, it's a new way to plot points called polar coordinates. Here we've got it in degrees, so r comma theta, so 120 degrees. So what you do though, notice that the r is negative. So let me rotate. Here's our 120 degrees. Now normally we would go out like 3, right? But the r connotates, if r is negative, then the ray is telling you to extend it in the direction opposite. The terminal side of theta. Okay, so instead of being there, we're going to go, since it's negative, we're going to go in the opposite direction, exactly opposite. 1, 2, 3. And there it is. Okay, again, that's with a negative r. So the r tells you to extend it in the opposite direction from the typical terminal side of theta. So let's do this one here. We've got r comma theta. Theta is negative pi halves. So normally we go, well, negative pi halves is right here. So here's my, normally I'd be right here and I'd go down 3, right? But since the r is negative, I'm going to go in the opposite direction. 1, 2, 3, and I'm going to put a point. So there's the point r comma negative pi halves. And by the way, so this is in polar coordinates, right? What is this in rectangular coordinates? What point is that in rectangular coordinates? X, Y. Can you guys say? Yeah, 0, 3. That's what it is in the old typical rectangular coordinates, but now we're going to express it with r comma theta with an angle, right? This next one's a good one to try. So go ahead and pause the video. Try that one, -3 pi fourths. Here's our r and our theta. All right, so I'm rotating -3 pi fourths. -4 pi over 4 would be negative pi. It's not -3 pi. It's not -4 pi over 4. That's -3 pi over 4, or -135. So that's where it normally be, but notice the r is negative, so I got to go in the opposite direction. That 1, 2, 3. There's the point, right there. Okay. All right. In the next part, now we're going to go ahead and figure out where the equivalent polar coordinate is given those conditions. So you're given this polar coordinate 5, here's our r, here's our theta, 300 degrees, right? So let's go ahead, if I was graphing that, I'd come around 300 degrees, and I'd go out 1, 2, 3, 4, 5. Okay, there's where it's at. Oops, right there. Okay. Now, give me a different angle, but the same spot. So my angle, give me a negative angle. So if this is 300 degrees, then what would that be right there? You're probably thinking to yourself, well, all the way around is 360 degrees, so the red has to be -60 degrees. Or if you want to go 300 minus 360, there's the -60 degree angle. So it's r, and I still go out 5, right? Going out 5. So r is positive, but -60 degrees. That's the same spot. So that's an equivalent polar coordinate. You know, and with a rectangular coordinate system, those are unique points. They're not unique in polar coordinate. So let's do part B now. Okay, here was our original 300 degrees and out 5. All right, so 5, 300 degrees. Now, part B, they want a positive angle, but I want a negative r, right? So what I'm thinking to myself is, so I want it to rotate to here in red. What would that be in red? And so that I can make my r negative. Well, here's how I think about it. If this is 60 right here, if I can get it to write, maybe it's not going to write for me. If that's 60 degrees, then that's 60 degrees, which means the red is 120 degrees. All right, those green ones are called vertical angles, right? And you know 120 plus 60, that's 180, right? Halfway around. So I know if I rotate, so let's do it. If I rotate 120 degrees, and then I let my r, remember I want it to end up 1, 2, 3, 4, 5. So I got to have my r be a -5. There's my r and my theta. It would work. Now, one more. So what if you have the angle be more than 360 degrees? Remember, originally it was 300 degrees and 5. That's where the point is. So if I go around once plus 300, right? So 300 plus 360, around once plus 300, then I get 660 degrees for my theta, and I still have a positive r. That is also the same spot in polar coordinates. So A, B, and C are all equivalent polar coordinates. So polar coordinates, again, they are not unique. Okay. Let's do some with theta now.
Back up really quickly.
All right, let's go ahead and draw this one first. So 3 pi fourths, it's not quite 4 pi fourths, 3/4 of the way there. In other words, it's 135 degrees. If you multiply it by 180 degrees over pi, you'll see that that 3 pi fourths is right there. And we go out 1, 2, 3, 4 is our r, distance from the pole. So there's the point. 4, 3 pi fourths, okay, r comma theta. Now they want a negative angle instead. So what would this be instead? Well, if you think about this being 135 degrees, then it'd be like 135 degrees minus 360 degrees, right? Well, let's just go ahead and keep it in radians. So 3 pi fourths minus 2 pi, or 3 pi fourths minus 8 pi fourths is negative 5 pi fourths. And so that would be the orange, negative 5 pi fourths. In other words, negative 225 degrees. And then the r would still be 4. So I want a positive r. Oops, I'm supposed to be doing this in radians. All right, what about if we do a negative angle this time? Okay, so let me erase this orange here for a second. Okay. So we're supposed to end up there, but this time we want a negative r. So I want to go to here and have it flip around. All right, so the question is, what is that angle, so that then I can have an r of a negative 4, right? An r of a negative 4. Well, it's 3 pi fourths is the blue, but then plus another 180 degrees on top of that. So it's 3 pi fourths plus another 180 degrees plus another pi. So 3 pi fourths plus 4 pi fourths is 7 pi fourths. So I want my angle to be 7 pi fourths. All right, so I'm rotating around here to 7 pi fourths, but then I got to make my r be negative 4 to flip that around. So it ends up being right there. 1, 2, 3, 4, and I end up at the same spot with a negative r. All right, one more. This time a positive r again, but I want the angle to be more than 360 degrees. I want it to be more than 2 pi, less than 4 pi. So I want to go around once plus 3 pi fourths. So my theta will be around once plus 3 pi fourths. So 8 pi fourths plus 3 pi fourths would be 11 pi fourths. That'd be my r and my theta on that. All right. Okay, this next one, this would be a good one for you guys to try. I'd go ahead and pause this. This one we've got r being negative 2. So we're going to rotate negative 120 degrees to here. Now normally I would go out, but this r is negative 2. So I'm going to go in this opposite direction. 1, 2. Okay, so here's where we got to end up, right? There's my negative 120 degrees. So that's the original point. Now I'm trying to find, I want an r that's positive, but a negative angle on this, right? A negative angle on this. So what I want to do is I want to keep going in the negative direction that much. How much more do I go than negative 120? I go 180 more. So negative 120 minus another pi. All right, so negative 300 is my total angle. Let me put that in red. That's my total angle right there, negative 300. That included pi more than negative 120. So negative 300 and a positive 2. All right? Okay, let's draw this again. Here's my original. Now let's do part B. Now I want a negative r, but a positive angle, right? So the question is, what is let's see, oh yeah, a negative r. So I got to go to here, so that the r flips it over to the other side, right there. So it's all but 120, right? All the way around is 360, but I don't want 120 degrees of that. So all but, so 240 degrees, right? Would be this green. So I want to rotate 240 degrees, but then I want it to flip over, so my r is negative. And so then it flips it over going in this direction. And there's the point. All right, how about more than one time around? Again, here's my original. Here's my original. So I want to go and let me fill in a little bit here. If that's negative 120, I know that this is 60 degrees, which means this right in there is 60 degrees. So if I'm trying to find how many times I go around more than once, then that'll be 360 plus that 60 in red. That's 420 degree angle. So I want a positive 2 on that. Positive r. Okay. All right, well, here's the equations we're going to use to convert from polar to rectangular coordinates. And let me give you a little background here on this. You know, we've got, say we've rotated theta. I'm out r distance to the in polar coordinates, right? But in rectangular coordinates, I'm out x and I'm up y. So how do these work together? And let me make this height here. Let me kind of dot this. All right. If I take the sine of theta, you know, this is right triangle trig. The sine of theta here would be y over r. If I solve for y equals r times sine theta, right? If I take the cosine of theta, that'd be the adjacent side over r. And I solve for x equals r cosine theta. And then we know Pythagorean theorem, x squared plus y squared equals the r squared. So these three are going to be very useful in converting from polar to rectangular coordinates. So let's convert this polar coordinate, here's r theta, into a rectangular point. And I'm going to go ahead and draw it first. I'm rotating pi thirds, so 60 degrees, right? I go out 1, 2, 3, 4, 5. I'm right here in polar, right? In polar. What is the xy then? Well, I'm going to say I know my x is r cosine of theta, and I know my y is r sine of theta. So let's go ahead, x equals r. My r here is 5. My cosine, my theta is pi thirds. And so I've got the cosine of pi thirds, which is root 3 over, I'm sorry, the cosine of pi thirds is a half. How's it doing that? So we got x being 5/2. Now let's do the r over here. Let's take the sine of pi thirds and the sine of pi thirds. And so we got 5/2, comma 5√3 over 2. And so in other words, I'm out 2.5 and I'm up 5√3 over 2, which is, I don't know what distance that is, but up a little more. And that's the equivalent xy to get to the same spot as the polar coordinate, right? To get to that same point. Remember, there's a unique rectangular point. The polar coordinates are not unique. Let's do another one with a negative r here. So r theta. So I'm going to rotate negative pi fourths. Here's my negative pi fourths. But that r being negative is telling me go in the opposite direction. 1, 2, 3, right here. Now find that xy. Find that xy. So I say, well, x equals r cosine theta. Y equals r sine theta. X equals -3 cosine negative pi fourths. I look on my unit circle, cosine of negative pi fourths is √2 over 2. So I got -3 √2 over 2. And then let's do over here, sine of negative pi fourths is -√2 over 2. If I look at my unit circle, negative times a negative is a positive. And there's my xy. So I'm going -3√2 over 2, and then I'm going up 3√2 over 2. There's my x. There's my y. And rectangular coordinates. Why don't you guys try this one? Go ahead, pause the video and give that one a shot. 2 pi thirds, or what was that, 120 degrees. So right there, but the r is negative. So it flips it around. Okay, so here's the point. That's where we should end up with our xy, right? So here's our r, here's our theta. X equals r cosine theta. Y equals r sine theta. So x equals -2 cosine 2 pi thirds. So I look up the cosine of 2 pi thirds, and that gives you a -1/2. So -2 times a -1/2, +1. Now let's find the y value. Y equals r sine 2 pi thirds. And then the sine of 2 pi thirds is √3 over 2. So the y ends up being -2 √3 over 2, or -√3. So this is xy, it's 1 comma -√3, or 1 comma, what is that, like -1.7-ish or something like that. All right, let's go ahead and convert now into rectangular equations. Oops. Is that moving on? Move. Okay. Oh, I'm supposed to be moving. Oh. And when they say converted into a rectangular equation, right now, see how it's in terms of r and theta? So we want it in terms of like x's and y's, right? And so what you do is you could go ahead and say, well, I know the secant is 1 over cosine, right? And remember, we know, so r equals 5 over cosine. And notice if I multiply both sides by cosine and cosine, then I have 5 equals r cosine of theta. And remember, x equals r cosine theta, right? That's my x. So there it is, x equals 5. I've got a vertical line. That's what r equals 5 secant theta. That's what this polar equation is. It's just the vertical line, x equaling 5, right? Because you want to remember, x equals r cosine theta, y equals r sine theta, and x squared plus y squared equals r squared. Those are the three things you're going to use. Now let's look at this next one. Convert r equals 4 into a rectangular equation, r equaling 4. Again, remember x squared plus y squared equals r squared, right? So let's go ahead and square both sides. And now I got r squared. Well, I know r squared is x squared plus y squared. Remember, I'm trying to put it in terms of x and y. So I get x squared plus y squared equals 16. Well, guess what this is? This is a circle with a radius, and put radius squared, with a radius of 4. This is a circle centered at 0, 0 with a radius of 4. Okay. Let's look at this next one now. Let's convert r equals 2 sine theta minus 4 cosine theta. Again, this is in terms of r's and thetas, and I'm trying to get it into a rectangular equation. Well, I'm going to do something similar here, and this time I'm going to multiply both sides by r. And the reason I don't just square both sides, I still want r squared, but over here I don't want to square 2 sine theta minus 4 cosine theta times another 2 sine theta minus 4 cosine theta. So instead I'm going to think about this as r times each side. So I have r squared, which is x squared plus y squared, equals, and then I have r times 2 sine theta, so 2r sine theta minus 4r cosine theta. And why do I do that? Well, r sine theta, there's my y. R cosine theta, there's my x. And so what we have is x squared plus y squared equals 2y minus 4x. And now what I'm going to do is I'm going to add the 4x. Let me take that over to here. Let me subtract the 2y on both sides, and I'm going to complete the square. So let me come up here. X squared plus 4x, I'm going to leave a space. Y squared minus 2y, I'm going to leave a space, equals 0. And I'm going to complete the square by taking this term over 2, 4 over 2, and squaring it. That's the number I want. So 2 squared is 4. If I add it to this side, I got to add it to the right-hand side. And now notice this will factor. X plus 2 times x plus 2. See how that factors now? I completed the square. And then over here, I'm going to take that term, negative 2 over 2, and I'm going to square it. Negative 1 squared is a positive 1. And now this will factor, and don't forget to add it to the other side. I almost forgot to add it to the other side. I'll factor into y minus 1 minus y minus 1. And then I got 0 plus 4 plus 1, or 5. And so notice again, I've got a circle. X minus h squared plus y minus k squared equals r squared. I've got a circle with a center at negative 2, 1. Here's the center of the circle. And with a radius of the square root of 5. Right? But here's my answer. I just wanted to write it as a rectangular equation. So that's what this represented. It represented a circle centered at negative 2, 1 with a radius of the square root of 5. Last part of this is we're going to convert from rectangular now to polar coordinates. Okay, and so you want to again remember x squared plus y squared equals r squared, and then we'll kind of talk about those second lines there. I'll kind of walk you through that, but let's go ahead and look at this first one. Convert this rectangular coordinate, so negative 3, 3, into a polar coordinate. Well, if we're going to find it as a polar coordinate, I'm going to need to know theta, and I'm going to have to know r, right, to do that. And so the first thing I'm going to do is, since I have this polar coordinate, I'm going to go ahead and drop this straight down and put in, well, that's a -3, that's an up a 3. And step number 1, I'm going to say x squared plus y squared equals r squared. So I can use the Pythagorean theorem. So -3 squared plus 3 squared equals r squared. So I got 9 plus 9 equals r squared. I got r squared equals 18. So I got r equaling square root of 9 times 2, I get 3 root 2. Okay, there's my r distance. So from here to there, I now know is 3 root 2. Okay. Now the second thing I'm going to do is I'm going to use theta prime to solve for theta. So step 2 is I'm going to say, well, I know the tangent of theta is, I'm looking at the black theta prime here, is opposite over adjacent. So I'm going to use right triangle trig here. So I know the tangent of theta is -1, right? And so if I think about solving that, if the tangent of theta is -1, or theta is the arc tangent of -1, that's the same thing, right? So if I think about solving, how do I solve the arc tangent of -1? Set that equal to theta, then we know tangent of theta is -1. Tangent, I'm only looking on a unit circle between -pi-halves and pi-halves because that's where we had to cut off. That's where we had to cut off the tangent in order to find an arc tangent, if you remember that. And so where does the sine over the cosine give you exactly -1? Well, we know it's right here at when the sine is -√2/2 and the cosine is +√2/2. That would give you -1, right? Well, where is that? What's that rotation? That would be a -pi force. So that's what your theta is. -pi force. So the arc tangent of -1 equals theta, that's your -pi fourths, right? That's -pi force. Now we don't want, let's draw where -pi force is. This is -pi force. Now, is that the one that we want? No. In other words, or -45 degrees. No, that's not the one we want. We want, do it in red. We want this one, right? Well, if this is 45 degrees, then that's got to be 135 degrees, or 3 pi force. So if you want to think about it as theta, the theta that you actually want is -pi force plus pi. You can just add pi to that, and that'll give you the theta that you want here. Okay, and that's because if you're in the second or third quadrants, which we're in the second quadrant, you can just follow that, right? So r theta. Let's do another one here. This time we've got -2, -2 root 3. -2, and then down, oh, what's that? -2 root 3 is like -3 point something. So -2, -2 root 3. This is our x and our y. Okay, and we want it in polar coordinates. So we're wanting that theta right there. Oops. Theta. Okay. So number 1, x squared plus y squared equals r squared. So -2 squared plus -2 root 3 squared equals r squared. 4 plus negative 2 squared is 4. Root 3 squared is just a 3. So we got 4 plus 12, we got 16. So it looks like our r ends up being 4. So this is a distance 1, 2, 3, 4 out there. Right? So we now know the r distance from the pole out. The second thing we do is we're going to use this theta prime in here. I'm going to say, well, the tangent of that theta using theta prime is opposite over adjacent. So the tangent of theta is root 3. And so if we run the arctangent on that, the arctangent of root 3, and this is looking between negative pi halves and pi halves, then that theta would end up being pi thirds. Right, the arctangent of root 3. Or if you want to go back, if you're thinking about where does the sine over the cosine equal root 3, right, then you'd have to have the sine being root 3 over 2 and the cosine being a half. Well, that happens at pi thirds, right? So the arctangent of root 3, pi thirds. Now, pi thirds is only 60 degrees. All right, we don't want oops, what is this thing? We don't want the 60 degrees. We want the whole 60 plus 180 right there, right? So we want pi thirds plus pi. So pi thirds plus 3 pi thirds, 4 pi thirds is what we actually want. In other words, 240 degrees, 60 plus 180, 240. So the r is 4, and the theta is 4 pi thirds. That's the polar coordinates for that one. Okay. Alright, so this one, I'm out only a distance of a half, and then I'm down negative root 3 over 2. So let me draw a triangle. I'm to the right a half, I'm down root 3 over 2. That's my x and my y. I'm trying to find my r, first of all, for the polar coordinates. X squared plus y squared equals r squared. 1/2 squared plus looks like r squared equals 4/4 or 1. So our r is 1. Now number 2, here's, I'm trying to find theta, whoops, theta, but I'm using theta prime to do that. So tangent of theta using theta prime is opposite over adjacent. So the tangent of theta is negative root 3. So theta, if I run the arctangent, that will spit out theta being negative pi thirds, or negative 60 degrees. So it's saying this is negative pi thirds or negative 60 degrees. And so, I mean, you could write it as r comma, that's not incorrect, but we want a positive theta. So we want the one that's in, I'll put it in green this time. We want the theta being positive. So that would be negative pi thirds plus 2 pi. So negative pi thirds plus 6 pi over 3, so 5 pi over 3. That's the r that you want, if you're going to have a positive r at least. But again, that's not incorrect. But if you want a positive theta, it is. Got to be the one there in green. All right, let's move on here. X squared plus y squared equals x. That's a rectangular equation, right? Notice it's in terms of x's and y's. All right. We want it in a polar equation. We want it in terms of r's and thetas, right? Well, we know x squared plus y squared. We know that is r squared. And then we know x, remember x is r cosine theta. So we got r squared equals r cosine theta. I'm going to go ahead and subtract r cosine theta on both sides, set this equals 0, and factor an r out. And then I can set each one equals 0. So r could be 0, or r minus cosine theta could be 0. Let me add cosine to both sides. So r equaling 0 and r being cosine of theta would be our polar equations for that x squared plus y squared equals x. Let's do another one. 4x squared y equals 1. Remember, x is r cosine theta, so x is being squared. X is r cosine theta. And then the y is r sine theta. And this equals 1. So I'm going to go ahead and replace x with r cosine theta, replace the y with the r sine theta. And so we got 4r squared cosine squared r sine theta equals 1. And so we have 4, looks like I got 3 of these r's, cosine squared sine theta equals 1. I'm just going to go ahead and solve for r cubed. So let me divide it all by 4 cosine squared sine, this side 2. So I've got r cubed is 1 over 4 cosine squared sine. And now I just want to take a third root. I want to solve for r. So r ends up being the third root of 1, which is this 1, over the third root of 4 cosine squared sine theta. All right, one more here. Y squared equals 2x. Remember, y is r sine theta, so y is being squared. X is r cosine theta. So we got r squared sine squared equals 2r cosine theta, but let me subtract 2r cosine theta from both sides, so I have it equal to 0. And then let me factor an r out. So I got r equals 0, and then I got r sine squared minus 2 cosine theta equals 0. I'm going to solve that for r. I've got r sine squared equals 2 cosine. Now let me divide both sides by sine squared. So 2 cosine over sine squared. In other words, let me write that as cosine over sine. So I have r equals 2 cotangent cosecant theta, and there it is. R equals 0 and r equals 2 cotangent cosecant theta. Right? Well, thanks so much for taking notes. See you guys next time.